This lesson is on the layers of the Earth. There are two ways in which Earth's layers are classified. The first one is by composition, or what type of rock each layer is made of. The second way to classify Earth's layers is by mechanical properties, or the way in which each layer moves. Sometimes you'll see the word behaves in place of moves, but what they're referring to is movement, even if they use that word behave. Alright, before we can discuss Earth's layers by composition, we need to know the difference between felsic and mafic rocks, which are classified according to their silica content, or silicon dioxide content. Alright, felsic rock is any rock containing more than 65% silica. Intermediate rock is any rock that is between 55 and 65% silica. Mafic rock is any rock that is between 45 and 55% silica. And then ultramafic rock is any rock that has less than 45% silica content. So again, the rock types are all based on how much silica they contain. The more they contain, the more felsic the rock is said to be. The less silica that the rock contains, the more mafic it is said to be. Alright, and here we have a chart. We don't have to focus on everything on this chart, but there's some very important things we need to know, some very important differences between felsic and mafic rocks that we need to know. Alright, so felsic rocks, as you can see here, are lighter in color and weight. Felsic rocks can be clear sometimes. Usually they're white colors or light grays, sometimes pinks, light greens. Okay, and they're also lighter in weight. Okay, felsic rocks are not as heavy as mafic rocks are. Now, on the other hand, mafic rocks, they're going to be darker in color. They're going to be darker grays, black, dark reds, sometimes dark greens, and they're also heavier in weight. Okay. And here's the reason, all right? Felsic rocks, of course, like we said earlier, have higher silica content, and therefore they have less metal content, so they're lighter in weight. Now, on the other hand, mafic rocks, they have less silica content, but they have a lot higher metal content, and that's why they're much heavier, okay? Now, also, another difference between felsic and mafic rocks is felsic rocks do not take as much temperature to melt as mafic rocks do. Okay, so probably the most important things for going forward in this unit is that felsic rock is lighter in weight and mafic rock is heavier in weight. That's one of the main things to remember, and you should make sure that becomes a part of your knowledge going forward, because it'll help you a lot, especially when we get to plate tectonics. Alright, so now we're going to talk about Earth's compositional layers, which are the crust, the mantle, the outer core, and the inner core. Alright, the crust of the Earth is less than 1% of Earth's mass. Okay, so it is a very thin layer on the outside of the Earth. It's the layer that we live on. A lot of times when they try to give somebody the idea of how thick the crust is on the Earth, they compare it to a basketball covered in a sheet of paper. And the crust would be to the Earth what the sheet of paper is to the basketball. So that helps you imagine that the crust is a very thin layer. There are two types of crust, oceanic crust and continental crust. And the names kind of say it all. The oceanic crust makes up the ocean floors, and the continental crust makes up the continents. All right, continental crust is felsic. It's lighter in weight, so it rides up higher on the layers below. All right, then oceanic crust is mafic and much heavier, and that's why it lies a lot lower down on the layers below and forms the ocean basins. There'll be a little more on that later. All right, next we have the mantle. The mantle consists of hot, dense, semi-solid ultramafic rock. All right, so the rock in the mantle is not fully melted into a liquid, but it's not a solid either. It's not a true solid either. A lot of times the consistency of the mantle is compared to silly putty. It's very thick, but if you hold it up, it will flow. Okay, it can move. It can kind of flow although very slowly. All right, so the mantle makes up about 68% of Earth's mass. It is the thickest layer of the Earth. It is the largest layer. All right, next we have the core. All right, the core is the very hot center of the Earth, and it makes up about 31% of the planet. And most of the time we talk about the core, we divide it into two separate layers: the outer core and the inner core. Okay, the outer core is liquid. It's melted iron and nickel, and it's liquefied. Now the inner core is mostly solid iron metal. Now here's the thing that's funny about the difference between the outer core and the inner core. All right, the inner core is hotter than the outer core. All right, but the outer core is the one that's melted and liquid, whereas the inner core is still solid despite being hotter. And the reason why is that the inner core, the pressure, there's so much pressure on the inner core from all the layers around it that the molecules of that iron metal inner core don't have enough room to move to melt into a liquid. Okay, so despite the fact that the inner core is extremely hot and the hottest layer, it's still solid because of all the pressure of the other layers around it. All right, now we're going to talk about another way to kind of look at the Earth and divide it into layers, and this is by mechanical properties. Okay, so now we're dividing the Earth into layers based on how they move, how those layers move, or sometimes they're how they behave is what we say. All right, so the lithosphere is the outer mechanical layer. It's composed of both the crust and the rigid solid portion of the upper mantle. Okay, so the lithosphere as a whole behaves as a brittle rigid solid. It will not bend much before breaking. Okay, it's very hard and very brittle. A lot of times they compare it to peanut brittle, if you've ever eaten that. That's a sweet food that's very hard, and it's just, you can't bend it very far before it breaks. All right, the asthenosphere is up under the lithosphere. All right, and the asthenosphere, it behaves much like what we said with the mantle did. Okay, we're talking about a semi-solid layer here that is plastic-like and can flow. All right, it's not totally liquefied, but it's not totally solid either. Okay, it's gooey and it can flow. Now the lithosphere floats on top of the asthenosphere. Okay, the heavier parts of the lithosphere ride lower than the lighter parts. Okay, so the heavier parts of the lithosphere would be the mafic oceanic crust. Okay, it's heavier because it's mafic, and it rides lower and it forms those ocean basins. All right, the lighter parts of the lithosphere are going to be the continental parts. They're felsic and they're lighter in weight, so they don't sink down on the asthenosphere as much as the continental crust does. Okay, so here we have Earth's layers by mechanical properties, and again you have the lithosphere, which is brittle and solid, and it floats on top of that semi-solid plastic-like asthenosphere, with the heavier parts sinking down lower on top of it and the lighter parts riding a little higher on top of the asthenosphere.